Then I would like to welcome Maxime on the stage. Hello.
Hello, Andy.
End of the world.
Well, good morning to you and good evening to me, I guess.
Yeah, it's how late it is? 8 p.m.
Yeah, just 8:05 up here and down here in New Zealand.
Yeah, great. I'm very happy to see you and to hear something about the insights of Silverstripe, how things work and how to customize it. Have fun on the stage. Thank you very much.
Thank you. So, you guys see my screen? Hopefully, yes, there we go. Okay, so today we will be talking about the Silverstripe UI stack. But before that, we will talk a little bit about me. So I'm principal developer at Silverstripe Limited in New Zealand, but I'm originally from Canada. So I work on the CMS squad, which is the team internally at Silverstripe that maintains the Silverstripe CMS on a day-to-day basis. And aside from that, I'm also a core committer on the Silverstripe CMS project. Now, just a quick overview of what we're going to be talking today. So today I'm going to talk to you about how the Silverstripe CMS front end is put together. My talk will have two broad parts. The first part will be a self-commiseration. We'll look back at how we ended up where we are today. And hopefully this will let us better understand some of the decisions and mistakes that were made at the outset of Silverstripe CMS 4. In the second part, we'll deal with the way the Silverstripe CMS front end works in practice today. So I'll try to give you a high-level overview of how the front end stack is put together and how you can actually interact with it. A quick disclaimer before we get started. This is not a Webpack, React, Redux, GraphQL crash course. These are topics that are quite big. There's a vast array of resources on how to learn from them online, and by people who are a lot more knowledgeable about each of these individual topics than I am. So we're mostly going to deal with the idiosyncrasies of Silverstripe CMS, and then we'll try our best to get you started and actually like playing with it. Different people will probably get different things out of this talk today. So there's going to be some high-minded bits that will probably appeal to everyone because all developers love a good project gone wrong horror story, especially when it didn't happen to them. There's also going to be some very in-the-weed bits that might not make a lot of sense to everyone, but my hope is that everyone will get at least a little something out of the talk today. And if most of you walk out of here with some understanding of how to rebuild the Silverstripe CMS front-end library and maybe how to do a basic pull request, I will have accomplished my mission. So let's get into it. So first we'll have a brief history of this. In the before times, back in March 2018, Drake's God Plan was topping the charts. Some dude had just sent an electric car in space for some reason. The universe got a little darker when we lost Stephen Hawking. This bloke joined the Silverstripe open source team. And Silverstripe CMS 4.1.0 just got released. We were still spelling Silverstripe with two uppercase S in those days. So Silverstripe CMS 4 was still brand spanking new. Developers were trying to figure out the best way to upgrade their Silverstripe CMS 3 projects. Silverstripe CMS 4 still had some rough edges and there were a lot of kinks to work out. But the major architectural decisions or mistakes had been baked in by that stage. Speaking of kinks, our front end at the time relied on a bunch of cranky legacy dependencies. First, we had jQuery plus 10 or so jQuery plugins with varying degrees of support. On top of that, we had our own in-house jQuery plugin called Entwine, but the only person in the world who really understood how it worked had decided to bugger off to Bangkok on some sort of spiritual journey or something. And he wasn't answering emails. We were still generating most of our HTML output from SS templates and shipping it into the front end with AJAX requests. We had a bunch of REST APIs, but we were not following any discernible conventions, and they were generally poorly documented. Accessibility was a problem. A lot of the tech was on its last leg or was about to be deprecated. And it was becoming difficult to find and hold on to devs who understood this architecture. But that was all okay, because right next to our old legacy cranky stack, we also add a brand new, shiny, new, modern, cutting-edge CSS JavaScript stack. So we would use Webpack and Babel to build our front end. Our UIs would be divided into reusable components built in React. We would use a modern state management solution like Redux. All our forms would be outputted as form schemas and then rendered with Redux form. Our backend and front end could communicate seamlessly via a self-documenting and performant GraphQL API. Our front end would be built on top of the widely used and accessible Bootstrap and React UI libraries. All our style sheets would be written in Sass and adhere to the block element modifier convention. We were full of hopes because very soon we would port all our old cranky UIs to our awesome new stack, and our legacy stack would be a distant memory. So fast forward 3.5 years to the end times in September 2021. The complete refactor we dreamed of didn't happen. So our legacy stack today is still powering most of our UI. So that includes most of the CMS, grid fields, pretty much all the forms. And our shiny new UI stack is maybe not so shiny anymore. So for example, we're like 3 majors behind on the latest Webpack release. We're 1 major behind on our React mainline, and like pretty much like all the other dependencies are like at least 1 major behind something. So yeah, our beautiful hopes have been dashed so far. We did manage to put some wins on the board. So for example, the element area is entirely running on React, and the page history is all powered by React as well. But there's no getting around the fact that we didn't succeed in completely refactoring our UI to a modern JavaScript stack. So what went wrong? Shocking news, everyone. It turns out that most end users don't care about your flashy new JavaScript stack. Who would have thought? It's always going to be difficult to go to a product owner and say, hey, we're going to spend months of dev time to refactor something that pretty much works more or less as it is right now. Some other problems is that we ended up repeating some of the mistakes that we made in Silverstripe 3. So part of the impetus for like moving to a more modern JavaScript stack is we wanted to move away from having to maintain a lot of our own custom JavaScript abstractions like Antwine. So the idea was that we would implement our UI in our modern JavaScript stack, and we would rely on like common libraries that were well maintained by other people, and we would just focus on the key task of like building the CMS UI. Now the problem is that in the process, we ended up creating a lot of our own abstractions on top of our beautiful modern JavaScript stack, so that actually made it harder in the end to quickly migrate common UI elements to our new stack. And it also made it very difficult to onboard new developers on the open source team because it was such a idiosyncratic setup that we were using. Also, shit was on fire. There was a lot of growing pains with the Silverstripe CMS 4. So we were trying to get people off the Silverstripe tree as quickly as possible. So essentially, the big chunk of my first year at Silverstripe was just like spent writing upgrade guides for like Silverstripe CMS 4 and just working on the upgrader tool to make that process as painless as it could be. And we also had like key backend functionality that was sort of half-baked. So the public web route wasn't initially a thing in the like very first release of Silverstripe 4. Recursive publishing wasn't working. We were not happy with the performance of our GraphQL implementation, so we ended up refactoring it. Well, Aaron ended up refactoring it twice, and the third refactor is currently in alpha, as it's about to be released, hopefully one day. And they were like little boo-boos, like permanent. We couldn't have like a permanent link to a file. Every time you would replace it, you'd get a different link, which wasn't great. And also, like, we had like a significant SQL injection vulnerability around that time as well, and that had to be backported to Silverstripe 3 too. So essentially, like every quarter, we kept shipping new releases to address some of those major problems. and that didn't leave us any time to sort of do any substantial UI changes. And eventually, we just had to conclude that our glorious UI refactor was just not going to happen. And that forced us, essentially, since those times, we've basically been going through like the 7 stages of UI stack development grief. So we've been through shock, we've gone through denial, we've felt angry, we're trying to bargain our way out of the problem, we've been depressed, and I think we're finally ready to start testing like practical solutions that might get us out of this mess. And who knows, maybe one day we reach acceptance and find a way forward. So we're not going to completely refactor the CMS UI to React anytime soon. That's the simple reality, the situation we're in. We're going to carry some of our legacy jQuery Entwine setup for some time still. That doesn't mean we're going to completely blow up our modern UI stack. So for example, it would be completely insane to try to rewrite the asset admin area into jQuery Entwine. We will keep doing incremental improvements in React as it comes up, and we'll do whatever we need to do to keep the Entwine bits working pretty much indefinitely. The simple reality is that the Silverstripe CMS UI stack is weird. Like, we just have to learn to live with the weirdness while trying our best not to add to it. In practice, what this actually means is that we have to get better at explaining to developers how this crazy thing is put together and how they can actually interact with it. So for years, we have more or less resisted doing this because we kept thinking, oh, well, it's not good enough right now, and we're just going to refactor the entire thing anyway, so why waste time documenting it? And in practice, that's not going to happen. So part of the reason why I wanted to do this talk today is basically so we can make a first attempt at providing the proper guidance developers need to start customizing the Silverstripe CMS UI. So that's enough commiseration for today. So we're going to move on to the second part of the talk, embracing the weirdness. So Silverstripe CMS has several characteristics that lead to its weird stack. So the Silverstripe CMS Backend is a modular PHP application. It's managed through Composer packages. It's all running server-side. It doesn't require a build step to compile all the source code or as one executable binary or anything like that. Users all interact with the PHP backend via a single entry point in index.php. A normal JavaScript application might be modular, but it would normally be transpiled in one bundle that you just ship to the end user. And all your dependencies would be managed with npm or Yarn or some other tool like that. But the Silverstripe CMS frontend is not like your typical normal JavaScript application. So for one thing, it ships with a matching PHP code. It needs to be broken down into multiple smaller clients. Each of these clients need to ship with Composer rather than npm, which is very unusual for a JavaScript application. And then each little JavaScript clients need to interact with the other ones. But because of the modularity of Silverstripe, they cannot assume that the other one always exists, even after they've been transpiled to an actual JavaScript bundle. We also use a lot of third-party dependencies, like across all our modules, but they don't really have a clear way of like linking versions between each other. And we need a way to expose all of those bundles and dependencies to the end users in their browsers. But also, we don't want to send the same third-party dependencies down the wire like multiple times for each module. So right there, you have a rather complex and atypical setup of requirements for a JavaScript application. On top of that, we wanted to carry over some of the customizability that you get with the Silverstripe CMS PHP into the actual Silverstripe CMS UI. So in a perfect world, you would be able to insert your own JavaScript logic at specific points in our core JavaScript logic. Or you would be able to extend or even override some of the core JavaScript classes or functions. This is especially difficult because there isn't really a JavaScript library or framework out there that has come up with an awesome way of doing this that we could just copy paste in our code. So we didn't really have a nice approach to model in our own setup. And we sort of tried to do it, but in the end, we didn't get there. And this left us in like with a bunch of weird abstractions that ended up getting in our way rather than helping. Now, in the intro, I said that there would be bits where we might lose some of you. This is it. So I'm going to try to give you like a very brief overview of the key libraries we use on our JavaScript stack. So first, looking at that table, you might think that there's a clear demarcation between the modern stack and the legacy stack. But in practice, things are a lot more murky than that. So for example, there's quite a few places where we will use Entwine to dispatch Redux actions or initialize React components. The reverse is not true, however. So normally the React side is isolated from jQuery, and Entwine is not really aware of what's going on there. So like just a pro tip here. So if you're working on a React component inside Silverstripe CMS and like you're finding yourself doing jQuery calls, you're probably doing something horribly wrong, and you probably need to rethink your approach. On the dependency management side, we use Yarn to manage most of our dependencies, both in the modern and the legacy stack. The legacy side does require some libraries that are just not available as NPM packages. So in those cases, what we do is like we literally just take those dependencies and copy paste them in the admin modules. But you shouldn't have to worry about that in practice. It's just good to know that this is happening. Also, both the legacy and modern stack have the same build system. So if you build, so when you build, so your build will essentially build both of them at the same time. So at least that part is simple. But from here, things diverge a bit. So the modern stack is essentially a common like React Redux application. So if you've got some familiarity with that kind of setup, you're already like part way there. It uses a mix of GraphQL endpoint and REST endpoint to get data in and out of the PHP backend. And there's some test coverage with Jest and Enzyme and other testing libraries. The legacy stack is essentially a classic jQuery application with our own like Entwine layer on top of it. It uses REST and AJAX to communicate with the backend. It doesn't touch GraphQL at all, so there's no way of like doing a GraphQL query directly inside Entwine. And it doesn't have any test coverage at all, because when the thing got set up, it wasn't really a thing back in those days. So you don't need to have a solid grasp of all the concept you're seeing on the screen right now. God knows that I don't. But you're going to want to take some time to learn at least some of those texts if you're serious about customizing the Silverstripe CMS UI. And you need to have some understanding of how they fit together and what part each of those tech is playing. So one major complexity of our UI is making sure that all the modules can talk to each other. So Silverstripe admin is the central point that unifies everything. So all the shared dependencies and all the shared components all live inside admin. The other modules will have some components and some third-party dependencies that are very specific to their own use case. But in most situations, they will depend on admin for accessing like common components or common UI structures. The things that unify all these modules is a npm package called @silverstripe/webpack-config. So this is a custom package we use to contain shared configuration logic that all our client libraries use. And it tells each child libraries how to find common resource in admin. It also provides generic build logic for all our Webpack configuration. So if you're ever trying to create your own like UI library for Silverstripe CMS, that's definitely a package you'll need to require in your package.json file. So there's two broad ways that modules can share resources with one another. The first one is via some Webpack sorcery and a plugin called Xposed Loader. So for example, asset admin will use a badge component, which you can see here. So this file here is just a copy paste from an actual file in asset admin. But if you go around looking for badge inside asset admin, you won't find it. So that's actually defined in the admin module. And normally, like if you add an import like that, most Webpack would not know what to do with that. But basically, basically our Webpack config module tells all the other modules how to find the components defined in admin using a special Webpack loader called Xposed Loader. I'm not going to try to explain today exactly how the Xposed Loader works, and in practice, you don't really need to know how it works internally to get things done with it. The main takeaway is when you see an import for a file that doesn't exist in the current module, look in admin, it's probably there. Oop, I think I skipped a page there. No, okay, cool. Sorry about that. The other way that UI modules can share a resource is called the injector. Now, most of you will already be familiar with the PHP injector, which allows you to replace core dependencies with your own implementation using some YML configuration. But there's also a JavaScript injector as well, which was an ill-fated attempt at allowing customization of the core JavaScript logic. It was originally meant to do lots of wonderful things. In practice, the main thing it can do right now is allow some modules to register components that can then be recalled by other modules. I'm not going to try to give you a full breakdown of how the JavaScript injector works today, mostly because, honestly, I don't really fully understand how it works. I'm just going to quickly explain to you how to register and recall resources with it, so you're not completely confused when you come across it in either your own modules or in core modules. So there's three broad things you can register in the injector. So the first thing is React components, which like what you see here. There's Redux reducers, like this part here. And there's GraphQL queries, like this line here. So no matter what you are, sorry, I'm skipping ahead here. So initially, you'll probably want to start registering React components because that's the easiest thing to build and get started with. Then once you start building a more complex UI, maybe you move on to registering Redux reducers, which will allow you to sort of manage states and meet more complex scenarios. And then when you want to start like really building interactive application that need to fetch data back and forth from the backend, then maybe you start building your own GraphQL queries and registering GraphQL queries and then your front end. So no matter what you are registering, it's pretty much the same principle. So you just need to import the injector in your JavaScript file like this here. And then from there, there's two methods you can use to register either components or reducers or whatever you want. So the first one is the register many method. And the second one is the register function. So both of those functions do essentially the same thing. It's just that register many expects an object, and like each object, each entry in an object is just an entry that you want to register. And the simple register function essentially allows you to register one object at a time under a specific key. So in theory, you could just like instead of having one register many call there, you could have like two register calls instead. Yeah, so now that we've registered things in our injector, we need to get it out. So there's two broad ways you can recall objects that have been registered in the injector. So the first one is to use the inject GraphQL IO order component. And essentially what those will do is they will pass either a component or GraphQL query results as props inside your React component. So those are, in React, that concept is called an IO order component. I'm not going to go into what exactly an IO order component is today. It's a pretty common React concept. So if you just Google it quickly, you'll find lots of very interesting and detailed articles. But in short, essentially, an IO order component is a function that expects to receive a React component, and then we'll enrich that React component in some way, and then return you another React component that you can use instead. So in this scenario there, for example, we've got a form, and then we will inject the upload field as a prop inside our form, and then we'll get the new React component that we could, in theory, like just render in a JSX file, and then that would add like the form plus the upload field component. The second way you can get objects out of Injector is to use a more classic approach, like the load component method, which essentially just like you give it a reference and then it returns you the component that matches that reference. Or you can literally just import the injector in your own file and then just call it directly and ask it directly for what you want. So this approach is mostly used in the legacy entwine logic part of the system, because basically jQuery doesn't really understand what a React IORDER component is. Normally we'll use it for, there's two main cases we'll use it for. So one is where you need to bootstrap a React component. So for example, the upload field is a React component, but it's a React component that we will use inside entwine forms, for example, for uploading files. So essentially what you have is you've got your regular entwine form, and then you'll have a bit of bootstrapping logic that essentially finds the upload field SS template HTML, and then we'll bootstrap the React component inside of that. And another common scenario you might see is like basically where like our entwine logics need to fire Redux actions. So in this scenario, this would be this line here. We would like, you could use the injector to retrieve the dispatch method from your Redux store, and then you could pass an action to that, and then that would fire some action inside the Redux store, and then that could change the state of a React component somewhere. So again, this is not meant to be like a comprehensive explanation. The idea is just that when you come across something called the injector in JavaScript files, you have a general idea of what you're looking at, essentially. Now we have reached the momentous moment where I will attempt to do a live demonstration. We're not going to try to do anything like grandiose here today, so we're just going to try to make a very tiny modification to asset admin. And we're going to hopefully try to learn how the CMS UI library are structured along the way. So if I go in here, so here we've got like a pretty standard Silverstripe site. So we'll just log in here quickly to show you what we got. So essentially, it's like literally the straight up installer. And if we look, what we're going to modify today is this button here. So that's a button that allows you to sort of go up and down in your folder structure. So we'll just go straight in here. So we'll start by looking. So this is the root of our project. We'll start looking at our asset admin dependencies in here. So we'll just drill down to our Silverstripe folder, and we'll look at asset admin. And we'll look at the client folder. So essentially, like all our core libraries that have some sort of UI component pretty much follow the same structure. So if you know how one works, you pretty much know how all the other ones work, or got a general idea. So usually all our clients will be inside the client folder. And in there, you'll find a couple of things. So the first thing you'll find is the distribution files. So those are the files that are actually served to your actual users in their browsers. And those are usually built from the source file using Webpack. And obviously, you'll have little things like images, and inside JavaScript, you'll have your bundle there and a couple other things as well. And you'll have some bundle files, which is all the styles that you need to make the CMS look like the CMS, essentially. Another folder you'll have in there is the language. So that's basically just the internationalization bit. So you'll have like the various language that are available for that module, and you'll have the source files in there as well. So, but you'll notice that there's no source folder there. So like we've got distribution files, but we don't have the source files that have generated this. Now the reason for that is Composer is being smart here. So basically, by default, Composer, when it installs a package, it will try to download only what it needs to run the actual package. So it won't download all the source files or all the test files or all this kind of things. It will just download the sort of client itself. Now, or it won't even download the Git history also. So, but in our case, we don't just only want to run asset admin. We actually want to change asset admin. So to actually do that, we have to go inside our project. Stripecon. What we're going to do now is remove our Silverstripe dependencies to begin with. So our folder is gone now, and we're going to reinstall it. But this time we will tell Composer we'll give a special flag called prefer source. And this does essentially that installs dependencies, but this time instead of just copying what it needs to run the site, it will essentially do a straight git clone from GitHub. So you get all the git history, you get all the source files. So you're in a better spot to actually start developing things. So now if we go back in our folder here, we should see that asset admin should have a little bit more things now. So we will have an actual source folder this time. And we're just going to run through these here. So the first thing you'll want to look at here is the boot folder. So this contains all the bootstrapping logic to bootstrap essentially asset admin. So all these files. So these files here, you remember our friend the injector here. So this is where we register all the components. So basically, we've got a method here that will be called by the initialization logic, and we'll register all our custom React components. And then we've got two other files, so one for GraphQL queries and one for our reducer here. Yeah. And inside of there, you'll see that there's also an index file that just brings everything together. So basically, it just waits until the DOM is ready, and then it just calls all those methods to register all our methods. And then it does other initialization things like setting up routes and so on. So that's relatively straightforward, hopefully. And then, so once we're out of the boot folder, we'll go inside bundle. So bundle is the file that's actually targeted by Webpack when it's building the bundle. So basically here, you'll see that we're requiring boot, which will load that index file we just saw. And then we're requiring other things that are existing outside of that sort of bootstrapping asset admin logic. So like we're adding some bits of Entwine here, and also requiring some dependencies that other modules might use as well. So in practice, essentially, because this is essentially the entry point of our application, like when Webpack builds the bundle, it will jump in here and it will find all those modules, and it will drill down and find all the dependencies and then put them in one big file. Now we've got we've got the component and container folders here. So the component and container folders more or less just contains essentially basically a bunch of React components. Now, if you're familiar with the sort of Redux way of doing things in React, you'll probably be familiar with the distinction between a component and a container. So normally components are essentially UI only React components. So basically they kind of exist in isolation. They just receive props, and then they show something pretty to the user, but by themselves they don't do anything. So they're just there to receive props and render, and they're not aware of their wider state or surroundings. While containers are essentially, they have no UI element part at all. They just import a bunch of React UI components, and then they wire them in the state. So the containers are aware of the rest of the application, and they get the UI components to do things. Now, if you're a React Redux purist, you'll find that we're cheating quite a bit here. So our components have a lot of or a lot of our components have at least some state awareness, and a lot of our containers have at least some UI awareness. Yeah, essentially that's an area where we probably need to improve in the long run. In the Entwine folder, we have our jQuery Entwine logic. So in some clients, it's actually called legacy, but normally it's either going to be called Entwine or legacy. But in practice, it's essentially the same thing here. And if you open those, you'll find pretty classic jQuery file. So a nice thing about building those files is that you can actually use more modern JavaScript syntax. So you can actually do imports, import other dependencies in here, and import libraries and do fancy things like that, which is actually very helpful. But if you drill down, you'll find that it's a classic jQuery Entwine file. So you get all the you get your traditional jQuery selectors here. You can call Entwine on things. And you remember I mentioned that very often we'll use those jQuery files to bootstrap React components. So you've got an example of this down here, where essentially we've got we're getting a React component here, and then we're using the React DOM render method on an actual DOM element here. So basically, we're just bootstrapping that React component, getting it started. So basically, that's how we end up injecting React components inside our jQuery Entwine UI, essentially. Yeah, but hopefully, if you're familiar with jQuery Entwine, that should make some degree of sense, or at least as much sense as jQuery Entwine can make. And just drilling down, I'm jumping over some folders, either because they're pretty self-explanatory, like image, or they contain they're just non-standard, or they contain things that you don't really need to know in practice. Now the next folder we got here is state. Now that's essentially where all our Redux logic lives. So if you're familiar with Redux, that will be you'll find this pretty easy to understand. So essentially, the way Redux works is that it maintains a root state for your application, and then normally you'll want to divide that state in like little trenches, just to sort of in little slices, so that each slice manages an aspect of your application. So yeah, so essentially, if you open one of those, you've got the slice of this Redux state. And from there, it's like a pretty classic Redux setup. So you've got actions, you've got action types, you've got a reducer function, and most of them will have at least some tests to make sure that everything works. But yeah, like otherwise, like if you don't quite understand this, just go get a quick Redux tutorial, and then once you sort of learn to think in Redux, then that part here will make a lot of sense. Just drilling down through the folders here. So we've got styles. So in practice, most of our styles are actually inside the components themselves. But like there are some global styles that apply to all the applications. And in practice, when we actually build our styles, they're essentially all imported in this one file, and then Webpack compiles that down to one CSS file. So, for example, here we import some common functions from Bootstrap that just allow simplify that our like subfiles can use here. And in practice, every component that has styles here will essentially get an import call here. And then if we add some like custom UI, like site-wide style rules we wanted to apply, we could also put them in here or in a separate file and next to the bundle.scss file. And then those two folders we can skip quickly, but otherwise, like all the folders I've talked about today, they're pretty much following more or less the same logic. Now we'll leave our source folder for a bit, and we're actually going to look at our build setup. Now we'll jump in our package file. Now, if you're familiar with any sort of JavaScript development, package.json is like a pretty standard file. You'll notice we've got a name and a version here, but that's mostly just for show, essentially. Like that package is not published to npm in any way, and it doesn't have versions or anything. So it really is tracked through the composer to packages in composer. You'll find down here that we have a bunch of scripts. Now, pretty much all our clients share the same scripts. So if you know how one works, you'll know how the other one works as well. So we'll go through those in a minute when we actually use them. We've got some jest set up there. That's basically just telling jest where to find all your unit tests and where to find all the dependencies. So if you're setting up your own module and you want to write some tests for it, make sure to copy that in there and tweak it to your actual module paths and so on. Just going down here, you'll find that we have our magic Webpack Config module package. So yeah, so remember, like if you need to update if you're building your own module, make sure to remember to add that in there in your dev dependencies. We've got a similar one just for linting here as well. And just going down in the list here, that's pretty much all there is to see in here. Now the next bit is scary because it's the Webpack config, and Webpack configs are always scary. At least I find them scary. So you've got here we're importing our magic module that does all sorts of wonderful things. Now there's a couple, so we're getting a bunch of functions out of there. So those functions are like essentially just helpers that will basically allow you to build the sort of various part of your Webpack configuration. And then in practice, all of those functions expect normally at least one parameter, which is called pat, which is essentially just a list of places where they can find various things like source file distributions, legacy files, node dependencies, and so on. Yeah, so like in practice, if you decide to set up your own module, you'll probably need to copy paste some of that part in there and tweak your your actual paths here, and you'll probably need to tweak this part as well. The simple reality is like building Webpack configs is always a bit of a pain, no matter what. So you can probably copy paste this and then adjust it to your exact needs. But the nice thing is once you got it working, then you can pretty much forget about it and just leave it in the background to do its thing. I'm not going to try to explain all of this today. There's at the end of the talk, I will give you places where you can find simpler examples than this one. Now we went through our package.json file, we went through our Webpack configuration, and now we're going to go through Composer. But now some of you might be thinking, well, Composer, that's PHP stuff. Why are we talking about this? The reason why we're talking about this is because there's this magic bit here that's called extra and expose. Now remember, our users need to be able to directly download our distribution files. So that's where the expose logic comes from. So basically, there's all Silverstripe CMS setups will have a module called Silverstripe vendor plugin. And basically what that does is it allows each vendor module to essentially expose distribution files or files that browsers need to be able to download. So that includes images, JavaScript files, CSS, and in our case, language files as well. So the way that this module needs to know what it needs to expose. So in this case, you need to go in your Composer file and provide a list of paths that need to be exposable in your web root. Now you'll notice here that we've got our distribution files, we've got our language files, but we don't have our source file because essentially, in most cases, it won't be there anyway. And like the browsers don't need the source files, they need to compile distribution files that they can actually use to do things. Now, enough with all this Webpack setup and things. We're going to start looking at our back button now. So if I go back in my client source folder and I go in the component folder, you'll find that there is something called a back button here. So all our components or /container folder are pretty much all set up the same way. So basically they will have a name, in our case back button, and inside that folder you'll find the main component in a matching JavaScript file that has that name as well. Now, if our component was subdivided into a bunch of smaller components, then you would find that there might be other files in there that are imported back in the main file. In practice, our back button is pretty simple, so we just got one file. So if you open that up, if you're familiar with React, that should look pretty straightforward, essentially. So like that's a pretty classic React class component. You'll notice there that we've got like this, that we got our badge component, which is coming from admin. Now again, if you look for a badge inside admin, you won't find it. So there's the Xposed Loader logic figures all of this out for itself. So it will load it for you on the fly. And otherwise, if we just drop down, we'll find that, hey, there's a pretty classic render method here, which is, and then we're just returning a React component that we built throughout the render method. We've got some prop types. So again, this is not something that should, if you're familiar with React, nothing in there should be too scary. You'll notice very often that the main React component in our React file will very often be exported as a component. So that's mainly for the purpose of our tests. So we will go into those in a second. We'll normally have a README inside it as well. So basically, a README is just like a glorified markdown files that just tells you what the component's meant to do, maybe give you some sample usage, and then maybe explain what a couple of the props do and how to use them. So that's really just more like it's really just there to explain to developers who are looking at this the first time, like what the thing is meant to do. And if we drill down in our test folder here, you will find that there's two types of files there. So there's tests, which essentially is like jest files. So if jest files are essentially, jest is like the JavaScript equivalent of PHP unit essentially. So it's just a way of writing unit tests. So here you see that it's importing our component, our back button component, and it's just going to throw random things at it to make sure it behaves. It always behaves the way we expect it to in various scenarios. Now there's also a story file. So that's used by our pattern library. So the pattern library essentially just allows you to render each component in isolation from the rest of the application. So that's a very cool way to sort of tweak your UI and just like see their component on like specific isolated way from in an isolated view and remove from the rest of the application. Now we're going to go, that's what we're going to start doing right now. So basically, if I go in my terminal here, so the first thing I need to do if I want to build anything in our module is to actually install dependencies. So I will go directly in asset admin here. And remember, now we downloaded the client source, but we haven't downloaded the actual dependencies because that's not tracked to our GitHub module. So we will run yarn install, and no, it would help if I spelled install with L's instead of forward slashes. So what essentially it's doing is just going out, looking at our package.json file and just getting all those dependencies locally. Oh, it's going to take a while. It's going to think about a few things. But yeah, so it's done. Now remember, in our we said that everything depends on admin. So we also need to run a yarn install inside admin because admin will contain a bunch of dependencies that asset admin needs, but doesn't install out of the box. So right now we just cd'd back into our admin folder, and we're going to run a yarn install again. Now the admin module is actually quite big, so that one is usually take the longest to get everything. Okay, so we've got all our dependencies installed. Now we can actually start doing some coding. So the first thing we're going to do here is build our pattern library. So basically what we're typing here is yarn pattern-lib. And what that will do is it will go through all our installed modules and try to find all those story files we were looking at. And it will bring them all back together in one little mini application that will allow you to see all your UI components in one spot. So it's going to spend some time building things. Yeah, so the initial load is reasonably long, but that once that part is done, it's actually quite quick to rebuilding each individual bits afterwards. So, okay, so when it's done, it gives us a nice, pretty URL that we can open. And yeah, so like right now, what you're looking at is just like all the UI libraries that have stories attached to them. So for example, we can see what a button looks like. And in some cases, you can also like go in there and like customize and change props on the fly, which provides you some bits of information and so on. So that's actually a very useful tool, especially if you're working with designers, because basically you can you can give this to your designer, they can look at it and then play with the knobs. They don't need to write any code. They can just see what their UI looks like under different circumstances. So that's actually quite a cool, sorry, I've got a cat coming in here. So that's actually quite a cool way to interact and build UIs and to debug them and debug the look. Sorry, I will get rid of my cat for a second. The thrills of doing conferences from home. Yeah, so what was I talking? I was talking about our pattern library. So we've got our back button down here. So that's our back button. So you'll notice that it looks kind of weird right now because it's essentially it's designed to be a flexbox and to take the full height of whatever components it's in. So right now, because it doesn't have a container, it wants to take the full height of the pattern library. But yeah, so basically we're going to try to make a quick change here. So we've decided that we don't like the look. It's not permanent enough. We need the back button. Everybody's missing it. So we're going to change the class on it from secondary to primary. When I save here, you'll see that the right side here is thinking about a bunch of things. So it's doing stuff. So essentially, the nice thing about the pattern library is that it will watch all your files, and when you do a save on one or one gets updated, it will rebuild itself. And as you can see, it's quite quick, so it just took a few seconds. And if I go back to my library here, you'll see that my button's now green. I didn't even need to refresh anything. So this is actually like when you're tweaking the UI of your UI components, it's actually quite a powerful tool, because basically you can have your pattern library running in one monitor, and then you just keep tweaking the code, and you can see the changes right away in your other monitor. So this is quite a cool way of like approaching and debugging things and like tweaking things, because you get the results right away. And now we're quite happy with our green button here. So what we're going to do now is we're going to kill our pattern library, and we're going to try to. But we want to actually see our green button in the CMS. So we're going to go back to the asset admin library. And this time we're going to run a yarn dev. Now what yarn dev does, it essentially rebuilds our entire bundle. But it rebuilds it with a lot of extra bits of information. So it gives it, essentially it gives a lot of debug information and metadata, so that when you look at your console or your JavaScript tools in your browser, you get a lot more debug information about what's going on. So if we go back here and refresh our site, you'll see that our pretty button should be green now. And if we look at our dev tools, so you'll see that if I go under the component bit there, so that's React dev tools that you can install in any browser you're using. And you'll see we get quite a bit of information here. So we can select our button here, and you'll see that we can see the entire React virtual DOM here, and we can like highlight each component and see what's actually rendered. And we can like look at what props are being attached to each thing, and we got the name of each component that's being rendered. And so that's actually quite, like when you're trying to debug a module, that's actually quite a cool feature, because like you can go in and pull in the source for the admin or asset admin library, rebuild it in dev mode, and you get all that extra bit of information. So even if you're not planning on doing any development or fixing the bug, you can actually just pull it down, see what's broken, and see what's actually happening in this Redux state or in the React virtual DOM. Now another cool thing that you've got here is you can actually, instead of yarn watch, you can also instead of yarn dev, you can also run yarn watch. Now yarn watch does exactly the same thing as yarn dev, but like the pattern library, it will keep looking at your file as you change them. So in our case here, so if I go back here and decide to change the class back to button secondary and save, you'll see that it rebuilds itself on the fly. It's quite quick. And if I go back here, I have to suffer the indignity of having to reload my page. It's not quite smart enough to know that something has changed. But you can see now my button is back to being gray. Yeah, so if I go back in my, yeah. So I'm quite happy with that. So another cool thing you can do in here is you run test. So you can run yarn test, and you can give it the exact folder you want to test. So you can go client, source, component, back button. And essentially, when I run that, it will go in and it will just look at all the tests. And so that's a way of making sure that your change hasn't broken anything. So in our case, we see, hey, we got 3 green ticks. So we're all happy. And this command also supports the watch flag, which essentially does the same thing as watch. So basically, every time you make a change, it will rerun your test. So for example, if I go back in here and say again, it reruns my test right away. So like that's a really cool way of debugging your test, because you can as you write your test, you see the results right away. So if you change something and if you're trying to get one of those tests broken and you're trying to figure out why trying to fix it, then you you can keep making changes and make sure that you're not breaking any other tests as you're going along. So yeah, so we're pretty happy right now. All our buttons are, we like our green button. Our tests are all green. So we'll keep our changes. We'll stop watching our files. Another thing you can do is run the entire suites. So if I just take away the path here and just run it again, it will just go ahead and run the entire test suite for Asset Admin. Now you'll notice there'll be some scary warnings somewhere in there. Now that's just because we're using some deprecated React API and it's grumpy with us and wants us to update. Yeah. Cool. But otherwise it's all down there, and we can see that all our tests are passing. So we're happy with our green button. All our tests are passing. So now it's time to rebuild our bundle, but this time in production mode. So we're going to type yarn build here. And this is essentially doing the same thing as yarn dev, but with a couple of differences. So first, you'll see that it's running some linting on our source files and our style files. So that's just making sure we follow our existing conventions. And then if it's happy with that, then it moves on to running our tests again. So it's going through our entire test suites, and it's again running all those tests. And if all of those are green, it's going to move on to actually building the bundle. Now, this time it's going to build the bundle in production mode. So that means a couple of things. So that means that it removes all the debug logic and it minifies the files. So so now it's all done. So we've got our new bundle built. And if I refresh there, my button should be green. And you'll notice, like, for example, now if you look at our components, we're getting a lot less interesting information because like all our React components have minified names, and it's a lot harder to see what's actually going on. But otherwise, our bundle is a lot smaller in this scenario and a lot more useful for our end users. Okay, so in this scenario, if I just do a git status here, you'll see that we've got two files that have been modified so far. So we've got our component, we've got our back button component source file here, and then we've got our client distribution, which includes our updated back button source. Now, if we were trying to do a real PR here, so you'd be at the point where you maybe fork the asset admin module under your own name, then you commit your changes in here, and then you could open a PR from this, essentially. Now, so if I go back to our presentation today, can I go full screen? Maybe. There we go. So this concludes our exciting demo. Now, I know I flew through a bunch of commands here, so that I've got you a little cheat sheet to save you here. So remember, we got the composer install -- prefer source option there. So basically, that just allows you to install all your source, all your libraries from source. So getting all those source files and all that Git history. So remember, you have to remove your packages first. So if you want to install, so basically, like, if you don't remove your packages first, Composer will say, well, you don't need to install anything, so it's not going to download anything. And also remember that you have to install the module you're working on, and if that module is not admin, you also have to install admin as well, because all the modules depend on admin. And once you've got your source files, then you have to go into each module you're working on to install dependencies. So if you're working on asset admin, you have to go in asset admin and run a yarn install to get dependencies. And once that's done, you also have to go into admin and then do another yarn install to get the admin dependencies. And when you're in our admin, you can run the yarn pattern library. Actually, I misspelled it. It should be pattern-lib, not library. Sorry there. I will fix that in a later release. But yeah, essentially this is, basically that just allows you to get that pattern library to actually see what all the UIs you've got, and to actually update it quickly on the fly and see what it looks like in isolation. And when you want to actually see your new components in React or in the CMS, then you can run yarn dev to build the bundle in dev mode, yarn watch to keep watching your files and update the bundle as you go along, and yarn test to run all your test suites. And then when you're happy with your change, you're ready to do a PR or to commit to your own module, then you run a yarn build to rebuild your production ready bundle. So what did we learn today? So like I said, the point of the talk today wasn't to make everybody here a Silverstripe CMS UI expert. To actually do something useful with this kind of information, you would have to spend a fair bit of time familiarizing yourself with a bunch of other different technologies that feed into our main UI stack. But hopefully hopefully I've managed to demystify some of the basic steps needed to actually get started developing the Silverstripe CMS UI. And as I mentioned we're still working our way through our 7 stages of UI development brief. So that was just the first attempt at like starting to provide that guidance. And hopefully in the months to come, we'll be able to provide you better, more consistent guidance, not only in terms of talk, but also in terms of documentation and so on. Now, if you want to take some of the lessons you've learned today and take them forward into your own projects, there's a couple of things you can do. So the one thing I would suggest not doing is actually reading the doc, because our UI doc right now is pretty horrible. So I tried to read their existing doc in preparation for this doc, and I ended up being more confused than when I started. So it's really not up to scratch right now. So hopefully we'll be able to get in a better state soon, but like in the short term, just skip it. It's not going to be helpful. One thing that is helpful is a blog post that one of my colleagues at Silverstripe has provided. So Adrian has provided a really nice React form field tutorial. So basically that just walks you through all the steps you need to create a React form field inside Silverstripe CMS. And it covers a lot of the things I talked today, and then other extra little details that I didn't have time to get to. Another good place to look at is the Silverstripe's module template. So basically, this is a Silverstripe module template that you can fork or copy to get you started. So it's got all the Webpack wizardry set up for you with minimal customization needed. So if you're trying to create a new module, that's a great place to start. And if you're just trying to sort of add some customization to your own project, you can actually just copy all the build files into your own project and then tweak them a little bit for your paths and so on. And suddenly you've got like a pretty functional, you've got almost a functional Webpack setup, and you're ready to go. And also, thirdly, you'll remember that during my talk that I said that we should stop creating abstractions, and because it just adds more complexity. Obviously, I don't follow my own advice, so I do have a pet project called Recipe React, and the goal of that is basically to create a bunch of PHP abstraction that can actually be rendered as React component in the front end. So it's a work in progress. It does useful thing as it is right now, but again, it's like very much like it's an experimental thing. So you can try to run it if you want, but it's really do so at your own risk. Finally, I'd like to thank Andy and the rest of the Stripecon crew to have invited me to talk today, and I hope you've enjoyed my talk. And I'm not sure how much time we got left for questions now. Andy, are you still there?
Yes, I am here. Hello. Thank you very much for this talk. It was very interesting and very in-depth. Oh. Yeah. Thank you for the talk. It was very interesting and very in-depth. I also already discovered that the docs are not that recently updated. And it's a bit of a mess. It's not really clear what to do. It's a bit of a try and error whether something is still is still working like it's documented.
Yeah, I think part of the issue is basically, like I said, at the initial outset, we were trying to create these fancy injector abstractions that would make everything work. So we ended up documenting a lot of things that are like very in the weeds and don't really provide you an awful lot of guidance. And objectively, we were also trying to do like we were also trying to sort of create some sort of React crash course and Redux crash course. So like there's a lot of documentation there that's just like how to set up React, how to use Redux, and so on. And it's it's unfortunate that like in practice it's kind of a bit futile, because like we'll never be able to give you as good as a React crash course as like a lot of React experts can provide. Yeah.
Yes, of course. There was much discussion on the
we
channel,
are
but
the doc,
I'm sorry. Please continue. I want to.
Oh, okay. No, sorry, I lost my train of thought. So go for it.
Okay, I'm sorry. There was much discussion on the chat, but mostly about how to write Silverstripe the correct way. But there were some questions. First, we found a new feature of our tool.
The cat's name is Tabitha, and she always finds a way to jump on in the middle of the most inconvenient moments of my meeting.
Yeah. And now, yeah, great. And now a different question, more for the topic, but it's difficult to answer it now. They are discussing it on the channel. I think that's what the injector stuff is for, right?
Yeah, in theory, you could use the injector to override our core components if you wanted to.
Yeah.
I've never tried it, and I'm not sure. It might work very well for all I know, but I couldn't say right now. But like, yeah, if you were trying to do something as simple as adding like a purple button, then you could like, what you could do is just like load your own load your own CSS files after all our CSS files and change the button that way. So that would probably be a little bit more straightforward than going in and just like trying to override a button with another button. But.
Yeah. Okay. Maybe you can answer these questions in the channel, in the Stripecon EU channel, or on the better on the Slack channel than on the live chat, because we are waiting for Brett. Thank you very much. Thank you very much, Max, for this interesting talk.
Yeah, well, thank you very much, Andy, and hopefully I'll be back at some other Stripecon soonish.
Yes, we hope so too. Great. Thank you.